My name's Shah Selbe, and I'm going to tell you about a little bit of the work that we do in the field of conservation technology. Jacob's going to talk as well. We're two parts of Conservify, which is an organization I'll tell you about shortly. But I came into this work originally. My background is satellite engineering, so I worked at Boeing doing spacecraft propulsion systems. I'm now a fellow at the National Geographic Society, helping to think through how technology and conservation come together to protect the planet. So, conservation technology, you know, when many people think about engineers, they don't really think about this image behind me. This is us in the middle of an expedition that we were on in the northern part of Botswana in the Okavango Delta, which I'll tell you a small story about a little bit later. But we go across this delta in boats, and at this point the water was low enough that we actually had to strap up and drag the boats through the water like we were oxen. And being an engineer in that place, I have a very peculiar set of coworkers. This is one of the coworkers that we passed by. It's a Nile crocodile. This is actually a small one. We passed over Nile crocodiles that were 17, 18 feet long. So big animals. And this is the environment that we have to build the stuff we build in. So here, we're standing in water. Shortly after this picture, that year I set the expedition record for most leeches on me at once, which was 9. And as you would assume, doing any kind of technology work in those sorts of places, you have to carry a lot of gear everywhere you go because you can't quite anticipate what you're going to encounter when you're out there, and you learn things while you're out in the field. Like one thing that I learned in 2015 is hyenas like LED lights, so they'll chew on anything that has an LED light. So conservation technology, it's kind of a new thing that's quite popular now in the conservation and field science world. And it really comes as a result of where we are from a technology standpoint. So this is definitely an audience that I don't have to explain this side of things to, but we've come a long way in a very short time, and we can do a lot of really amazing things now for much cheaper than before. But on the other side of things, while we've gone through this massive technological ascent, from an environmental and a conservation standpoint, we're actually in a pretty big crisis. So things like overfishing and poaching are running rampant across the world. The extinction rate of animals nowadays is 1,000 times greater than what we would consider the baseline extinction rate. So the animals are dying off quickly, and that's happened in Earth's history multiple times before, right? You can talk to any grade school kid and they'll tell you about dinosaurs or the Ice Age, but this is the first time that it's actually happened as a result of a single species driving it. Does anyone want to guess what species that is that's driving it? It's people, right? We're driving that extinction rate quite bad. So we have a lab not too far away from here in downtown LA called Conservify, where we build open source technology tools for scientists out in the field or conservation organizations that want to better understand what's happening to the planet, monitor what's happening to the planet, and share that with the world. So we have everything that you would expect to have in that sort of lab, laser cutters, 3D printers, reflow stuff, everything. But it really allows us to build these tools that actually vary quite drastically from one project to the next, or one organization we work on to the next. So just generally in the field of conservation technology, everything you can think of, like all these tech buzzwords that you read about on the internet or you see on Twitter, there's people who are trying to shape this kind of technology now to solve some of these massive conservation challenges. We're doing some of this stuff. Colleagues of ours are doing other things. So I'll tell you some of the stuff that we're doing, some of the current projects that we have right now. One thing that biologists a lot want to know is where animals go, or where they go as a result of human activity, where they go in different parts of their life cycles and all sorts of stuff. So tracking animals has been something that's been quite popular for a while, but a GPS tracker that you want to put on an animal, if you buy it from one of the providers, the proprietary providers that exist now, is like $3,000, $4,000, $10,000 for a GPS tracker on a single animal. And I don't have to tell the crowd here, for a device that's basically a microcontroller and a GPS, sometimes a radio on it, charging $10,000 is absolutely absurd. So there's a few of us that have been developing open source tags that we can use on animals. And so at ConservifY, we're deploying it in 2 places this year. We're going to be going to Belize to tag sharks in the reef system that they have out there. And then we're also going to be going to Antarctica to tag sperm whales with some of these open source trackers that we use. Another project that we have is called Undersea Connection. So some of you guys may have heard of Rainforest Connection. This is an organization that a colleague of mine started and actually had a pretty successful Kickstarter campaign. His idea was, his name's Topher White, his idea was you could take old cell phones that people don't want anymore and you put a nice microphone on it and you write some software and you put it up in the rainforest and you can basically have those cell phones listen for logging activity or like motorcycles and stuff in the rainforest. And the thought was, if you do that, then you could start to catch people who are illegally logging in parts of the rainforest where you're not supposed to be doing that sort of stuff. And actually, the first time Topher went and deployed one of these systems, they put it up, and he found someone who was illegally logging right around the corner. So it's something that they've shown that's worked. We actually have a collaboration with them where we're taking that same technology. It's moved beyond the phones now into their own boards, and we put it in the oceans. In marine protected areas. So these are basically underwater parks in different parts of the world where we're trying to protect them. We're saying this is a special place. We're going to let the fish that live in this place grow, and then anything else that spills out, then like fishermen and everyone can kind of take advantage of that. But these are special parks. So we're putting these things in MPAs, or these marine protected areas, to be able to listen for vessel traffic as they come through. And we have a prototype that's in the port of LA right now, and we're scaling that up and deploying it in lots of places later on this year. And you could tell a lot acoustically. You could tell what kind of vessel it is. You could tell what kind of fishing activity they're doing. You could tell if if the reef system is a healthy reef system or if it's a dying reef system. It's a lot of information that you can actually get from that sort of thing. Another project that we had worked on is with NOAA, which is the National Oceanic and Atmospheric Administration, on creating a low-cost tool to track ocean health. It's called a CTD. It does conductivity, temperature, and depth profiles. So we created a low-cost open source one. And a lot of the work that we do also involves drones. So you guys have heard a lot about drones and the changes that's happened to drones. I actually just came back from the Republic of Congo on a drone project, which I'll tell you a little bit about right now. So in Congo, the type of gorilla that they have there is the Western lowland gorilla. There's actually quite a bit of Western lowland gorillas, and they're a little bit smaller than the mountain gorillas that a lot of people think about when they go to places like Virunga to go see those animals. But the crazy thing about Western lowland gorillas, they're still big animals, is they climb up trees. So this picture was actually taken, it was maybe 90 to 100 feet up in a tree as it's there. And so we're partnering with a researcher there who's actually probably the world's leading expert on Western lowland gorillas. And what she's studying is gorilla behavior. So this population of gorillas, they actually have this very unique behavior where they go to this very specific type of tree. They dig really deep and they eat a special part of the root that's on that tree. And the reason why that's interesting is that's not a natural gorilla behavior. It's something that one group of gorillas learned how to do and has subsequently taught to other groups of gorillas. So she's very interested. And the way that they study it now is they use camera traps. They put camera traps in these sorts of places, but they don't know where they should put those traps. So we came in and we did a whole bunch of drone mapping in that whole area to try and find more of those trees and model that part of the rainforest so that they can know exactly where those traps are. So I was there. I got back on the Sunday before last from doing that. And then we tested other kinds of radio technologies and other stuff so that we could put sensors and connected camera traps throughout those places so they don't actually have to hike out to all the places that they need to go. But the next project I'll tell you about is the one that I mentioned at the start that happened in Botswana. And the reason why I wanted to tell you about this is because this project actually influenced a big initiative that we have at ConservifY. That project was called the Okavango Wilderness Project. It's actually an official initiative at National Geographic right now, where they go year after year to this place to try and protect the Okavango Delta. So the Okavango Delta, if you haven't heard of it, is this magical place that's in northern Botswana. It's actually a series of rivers that flows into the middle of the Kalahari Desert, into a giant inland delta that basically just flows into the desert and evaporates. But it creates this amazing habitat for all like that charismatic megafauna that you think about when you think about sub-Saharan Africa. It's actually the healthiest population of African elephants in the world. There's 300,000 of them there, but like hippos and lions and crocodiles and everything that you would think about when you're there. It's a really remarkable place. And the reason why they wanted to protect that area was because the headwaters of the delta, all the water comes from Angola. And I don't know how much you know about Angola, but it's a place that went through 27 years of civil war. It's the most landmined country in the world. And now it's the second largest oil producer in Africa. So they're really changing a lot of stuff. And if you're mining, if you're prospecting for oil, all that stuff requires water, which could fundamentally change one of the most special parts of this planet. So we came in to better understand what the current state is and how those things can happen over time. You know, the first time we did how scientists traditionally do it, where we pulled water out and we actually ran tests on the water chemistry there. And then we started developing our own tools that would allow us to do that autonomously and set up these networks of sensors throughout the area. But kind of at its core, what the Okavango Wilderness Project is a wildlife census. The scientists were going year after year through this really special place, and they were counting wildlife. They were counting the number of birds they see, the number of elephants they see, all this sort of stuff as a means of doing kind of a annual census on that area. This is like a key tool of biologists when they're out in the field. But when we came into it, they were just doing it by writing it down in a notebook, you know. And then they would come back and someone would have the really horrible job of taking all that and putting it in an Excel spreadsheet, and that would sit on somebody's computer, and you know, no one would ever see the data, nothing ever would happen at it. So we said, all right, you know what, like everything you're doing is important. We can take all of that data that you collect and we can do something cool with it. So we decided that we wanted to actually take it all and make it open and make it live. So the way that the Into the Okavango project worked was we built this website called intotheokavango.org that all the data while we were on expedition, all the sightings, all the water quality data, the pictures we took, the heartbeats of the researchers, literally everything that we collected would be streamed up through satellite and come up live on this website. So if we were on expedition, you'd go to this website. I'm one of these S's that you see here, the bubbles there, and that's like where we were at that exact moment as we were going through this expedition. And we built the tool to be completely open, so anybody could take that data and do anything that they wanted with it. And that included all the sensor data that we had. We had sensors attached to the boats that we went down, so we got a water quality profile and 360 pictures the entire way. And everything that we collected was all correlated using GPS and time. Yeah, we did 360 pictures as well. So like you could put I don't know why that's not playing, but you could put on a pair of VR goggles and basically live through the entire expedition as we went through. And you could see on the website the way that we had all these little orbs or the actual 360 photos as we're going through. But the interesting thing was now we had data in a way that they didn't have it before. Before they just had some things they wrote down in a notebook. Now we had pictures and sounds and water quality data and animal sightings that was all tied to time and GPS. So you can actually start to see trends and really interesting data that would come out of that sort of stuff that you didn't see before. And we've heard all sorts of students and universities and other groups that have gone off and taken that data and done pretty cool things with it. But the other thing that we did while we were on expedition was we tried to really engage with the public. So we leveraged social media, all the tweets and everything that we would send would show up on the map as well. And so a great example of how we kind of reached out while we were there was in the 2015 expedition. We were in a part of Angola that was very difficult. There were sweat bees everywhere, which are these like really small, like fly-like animals that you'll have literally like 400 of them around your head at one time, and they're trying to get in your eyes and your ears. The water was really shallow. The river was really bendy. The weather was bad, and so in the interest of sharing everything, we complained about it on Twitter. And so one of our followers actually saw us complaining while we were on expedition and tweeted us back a message of support. That follower was Samantha Cristoforetti, which was a European Space Agency astronaut that was on the International Space Station at the time. And she took a picture of the Delta and tweeted us down this message of support, which I think you can imagine kind of like raised everybody's spirits quite a bit. So it was pretty cool. So that whole experience was pretty profound in terms of the impact that it had and the outreach that we had. So we wanted to take that and turn it into something that anybody could do the exact same thing. So Jacob will come up and talk about that.
Thanks, Shah. So my name is Jacob Lewallen. I am the other half of Conservify. It's primary nerd, so to speak, and I'm going to talk to you about FieldKit, which is basically what we spend most of our time working on nowadays when we're not doing some of these other side projects and that kind of thing. And I'm going to take a quick moment to give a shout out to some of the people that have helped us along the way to get to the point we're at now, because this has been very much a collaborative effort. We have a lot of volunteers, people that have spent quite a bit of time just helping us out, and here are some of them right now, just to, out of fairness. So what is FieldKit? I apologize for the market speak a little bit right here, but FieldKit it's a one-click open ecosystem for researchers and explorers and communities. And a lot of what Shah was talking about with regard to Twitter and data feeds into this process and this work we're doing with FieldKit right now. And it's global, it's distributed. And its primary focus is environmental data, but there's more to it than just the science and the numbers and that kind of thing. I'm going to start a little high altitude and then sort of drill down in the different parts because it's a little bit of a big undertaking. And there's a few sort of principles that we're trying to keep in mind as we work on this. It's got to be approachable. Not everybody that is going to be interested in this kind of thing is going to have the technical know-how to build it and design PCBs and assemble it and that kind of thing. So it's got to be really approachable, easy to use, but it's also got to have be research grade. So it's got to be something that people know the kind of data they're getting out of it is has these sort of this error and that kind of thing. And it's open source and extensible and free. It's a really big part of what we do. So everything you're about to see with regard to FieldKit it's on GitHub. There's repositories for it. You can go and clone repositories, run the code. You can send away for boards from Mosh Park and assemble it yourself in your living room. It's fine. FieldKit it's a platform. So it's a lot of different pieces. Well, 3 pieces, not a lot of pieces. The first being it's modular hardware, which I'm going to get to in a little bit. And there's an app, and there's a website. The app kind of ties the hardware and the website together, but the website's a little bit more than a website just with a bunch of numbers in it. The app is a little bit more than just something that moves data from the hardware to the website. And the hardware is just hardware, but it's also nice because it is a platform. It's a place where people can augment and add their own hardware, which we'll get to in a little bit. Shah talked a lot about Twitter. And sort of the engagement you get from combining just the science, things, heartbeat on expedition and the water quality and that kind of thing. And our goal with FieldKit is to be able to take these multiple inputs of information, whether it be social media or raw sensor data sitting in a riverbed somewhere, and combine it and aggregate it in a way and display it, whether it be on our website or some other source or destination. We have iNaturalist up here, and that's on a future slide where this data and this information doesn't necessarily have to go to this website that we're setting up. It can go anywhere. The idea is to just sort of build tools to funnel this information around and also provide the tools to gather that information. So right here, this is my opportunity to talk about the website. Because this project has so many different pieces, I'm not going to really get too technical, but I can tell you a little bit about what the website is, how the technology that it's based on right now. It's on AWS. We use Terraform a lot for that. The backend's written in Go. We use React and Redux for the front end. So there's a lot of, just basically what you expect out of a modern front end and back end stack nowadays. Postgres database, PostGIS. But one of our key offerings that we're trying to provide to people is there's an API and their data is there and they can get it and they can do whatever they want with it. They can share it and basically distribute that information however they see fit, whatever fits their needs. And that's information that doesn't include just the sensor data. That's information like social media, pictures, Instagram, Twitter, that kind of thing. Because one of the important things that you may have gotten from Shah's part of the talk is the story. It's really important not just that this data is collected, but sometimes it's really important the journey that goes into that data collection. So visualization and showing this data and the different streams of data is a really big part of what we spent a lot of time talking in the lab about the best way to present this kind of information. And so it's really important to us that it be consumable and easy to use and share and that kind of thing. I'm going to now talk about the hardware a little bit. And we actually have some of our prototypes here that we can pass around. And I have to, forgive me, because my background is computer science. I'm self-taught when it comes to designing hardware and PCBs. So if the EE people in the crowd can go easy on me, I'd really appreciate it. But FieldKit's modular. And so what we mean by that is that we have what we call our core board, which in this picture is this one right here. And that has most of the brains and sort of the orchestrating software and hardware. So it's got GPS. There's a Wi-Fi chip on there primarily for use with the app. It's got the charging circuitry. There's some serial flash on there and so on. In fact, there's one being passed around. It's the slender one, not the thick, tall one, and you can see what's on there. If you have any questions after, you can ask me too. But then we have all these other modules that are used to, we have sensor modules. For example, right here with the multicolored boards, that's our water quality module, which you saw on our previous slide. And we have weather ones, which is the one with these RJ11 jacks on there, and various other modules. And we have a collection of protocols that are used to communicate between the core and them, and this is all open source. And we provide the firmware so that people can make their own modules that they want. And it's easy enough to say, hey, if I want to provide data to the core module, all I need to do is implement this function, and it's in the FieldKit ecosystem. And that's one of our primary goals. And so it's tagged both time-wise and geo-wise and that kind of thing. And so yeah, so there are some instances where we don't necessarily need the modularity. One of those instances is with what we're calling our naturalist board, and it's one that's going around. It's got the grooves cut out on it, and that's an example of a board where we've taken previous boards, combined them into one, and we're creating this board for an app called iNaturalist. I don't know if anybody raise their hands. Anybody familiar with iNaturalist? No. So iNaturalist is an app where I can be out, in the Mojave Desert or something like that, and see like a flower or a cactus, and I can take a picture of it and upload this observation. And there are people, scientists online that will identify that. There are biologists that will tell me, oh, that's so-and-so in this genus, whatever. And what we're trying to do is sort of augment that data, because right now it's just a picture and a location. And so our hardware, what we're trying to say is, oh, let's take an environmental, reading of that situation. Let's take pressure, humidity, light level, and combine that and attach it to these observations. And over time, hopefully get an idea of what sort of environment it goes along with these these plants, these animals, and that kind of thing, and sort of add to that data, that corpus of information that's already very well vetted on or filled out on Naturalist. And so this is not a modular board, but it's the one that's being passed around. If you look at it. There's another sort of side of this, in that what we're doing isn't something that a lot of DIY or hacker people aren't doing in the garages already. But one thing that happens is people tend to learn the same lessons over and over again because it's hard to find information about a particular sensor or experience with a sensor in a certain environment. And so the idea is also that FieldKit would have a library where you could learn about how somebody, for example, in this situation, like what are the physical characteristics of this particular ultrasonic sensor, and will it fit my use case? And what are some gotchas in deployment, and what are my lessons that were learned, and sort of get an idea about choosing between the different sensors, because as we know in the electronics landscape today, there's a lot of options when it comes to the different kinds of sensors, and knowing which one will work best for your application sometimes isn't obvious, especially when you consider the environments that sometimes scientists in this particular field are dealing with. You don't really have, there's not a lot of, it can be complicated environmental-wise, as we'll get to in a little bit. An example of another thing we're trying to do, this is a Gurley price meter. It's for water flow. It's for detecting water flow. It's upright right now, but you dip it in the water and it measures the flow of water. And it was invented in like the early 1900s, and this thing is about $3,000. And it doesn't look like it costs $3,000. And so one thing we've been working with people to come up with an open source one that you can 3D print. And it may not last as long as that beauty on the previous slide, but it's a lot cheaper. And if it gets a job done, then I'm not complaining. And so right here is a video of the same, it's not the same one, it's a different color, but it's the same sort of design being tested. And so this is the kind of thing we see going into the libraries, not just information about sensors that are out there, but sensors you can make and deploy and tweak to your own needs if need be. So while that's this is where we're spending most of our time, there are certain places where we've actually gone and been able to test and use this thing, or this platform. And one of those places is, this is in the Peruvian Amazon at a place called the Boiling River. And that's a shaman. It was early morning one day. And this is not your regular kind of mist. And I'll get to that in a little bit. So I didn't know about this until last year. This is Andres Ruzo. He has a TED Talk on the Boiling River, and it's absolutely fascinating. And what he heard growing up in Peru was that he heard about a myth about this boiling river. And it's a river somewhere in the Peruvian Amazon that's boiling. And nobody knew where it was. And the funny part of the story is that he spent some time looking, couldn't find it, until one time he was at dinner with his aunt, and he was talking about his lack of success in this area. And she was like, I actually know where that is. I can take you there tomorrow. And so he did not believe her, so he grabbed his temperature gauging equipment, and off they trekked. Took them half a day to get there, but they got there. And so it exists. It's a river that's boiling. It starts cold, and then water seeps up out of the the Earth's gradient along different parts of the river and makes it incredibly hot at some point. This is a video that is trying to play this video. And so we built a little buoy that you can see here. On this expedition, people refer to it as my pet. And it had a very early prototype of FieldKit in it with one of our water sensors. This was back when we were in the prototyping off-the-shelf phase, so it was our own PCB, but it was stuff through-hole soldered onto a board. It had GPS, a radio, the water sensors, and I had a handheld unit that was listening to the radio signals and telling me where it was at. The idea being, if I need to find it, I need to know how close I am. And it would also show me the sensor readings. And so you can see this steam rising off the water, because that water is very hot. Here, it's about 70 degrees Celsius, but there were parts that were 100 degrees Celsius, very easy. And so this is one of those jobs, too, where you spend some time going back to the physics in the open source library. You spend a lot of time looking up, what are the tolerances of my sensors right now? And I can say that there are parts of this river that I had to use spare sensors because it was very hot. One other thing that happens I'm gonna let this play. This has audio. Can we get?
Well, we got it out of that box over there, which is good.
The current was not very strong.
Oh, wow. Over there. Go little drone probe.
My little pet.
Go little drone.
What it's doing.
Stop. Don't you dare.
These fucking currents, man.
Asshole.
Careful.
There's a bunch of string right here.
I think we just gotta wait for it. I think it'll, if it get it that way, the current will take it eventually. Eventually. Also, we can throw rocks at it. Which is what we ended up doing. We ended up throwing rocks at it. There are some things that when you're going, you saw the picture that Shah had of all the bags. There are some things you just can't prepare for, and it's easy to forget how some things that would have been simple on expedition can be very difficult when you change one thing. For example, it would have been very easy to get that buoy back if the water wasn't scalding and dangerous. And so it's always a learning experience. It definitely teaches you one of the core principles of engineering is like, what can I anticipate? What can I learn from? Swinging from one end of the spectrum to the other, there is another project we have, which is the glaciers. And as you know, right now the Arctic and the Antarctic are in huge danger right now. And it's one of the biggest areas you can see the effects of climate change and that sort of thing. And so we had a project recently in Banff National Park on the Bow Glacier to monitor the effects of climate change and the effect it was having on that particular glacier. And this was probably one of the coolest experiences I've ever had, and as you'll see in a bit, we had a lot of equipment for this particular project. And the project was to set up a glacier monitoring station on top of this glacier. And it was not a very lightweight station, it was a very heavy station, and so you couldn't just hike up within a backpack. And so we needed to chopper in a lot of the gear and the equipment. And it was definitely a unique experience. But there was a lot of preparation that went into it. Here's Shah. He actually hiked up with this, and I think you hurt your ankle on this hike. Yeah. So we had geophones and accelerometers. This is us doing like a sort of a trial run to see if what we had in mind was going to work. And sort of seeing, can we see what's happening on the glacier and that sort of thing. The way when a glacier melts, it melts at the interface between the ice and the bedrock, and it looks it's a lot like an earthquake or an icequake. And so you can get some, so that's why we're on the rock here and that sort of thing. So here is the station that eventually got set up, and I'll talk to you a little bit about what you're seeing here. So we have a huge tripod here. At the very top, there's a wireless link that goes down to a very similar setup station at a lodge. That's about 4 kilometers away, and then a bunch of solar panels. This right here is another part of the wireless link. And then these 3 Pelican cases are filled with car batteries, about 15 car batteries. And the 4th Pelican case on the left housed all the electronics. And it did not look this messy when we deployed it. I can assure you that. We were looking around for better pictures today, but this is the best we could do. This is actually in the lab as we were setting it up. But I wanted to give you guys an idea of what it looked like inside that 4th Pelican case. So on the left is our charge controller for the solar charge controller for the batteries. In the center is an accelerometer, a very fancy accelerometer, actually from a company here in Pasadena. And then there is a geophone. The ADC for the geophone is right there, and then a Raspberry Pi with some hard drives for storing the data. We have an other mill in the lab that we use to prototype, especially our through-hole boards. But eventually, that was we sent away for a nice, pretty purple board for that one, and that housed all the voltage stuff because a lot of these things needed different voltages. And then one of my final slides is just an example of the kind of data that we get off the glacier. We work with a glaciologist. His name is Jeff Kavanaugh, and he is in Edmonton. And we sent him some of our data, and he produced these. I call them little balls of yarn, because I actually don't know what I'm looking at, but it's cool looking. All right, and then Shah's actually going to talk to you about some of our future projects that are coming up.
Yeah, so that's actually like how the glaciers. Oh, sorry, yeah. That's how the glacier's moving in three-dimensional space, and these are like kind of boring, kind of academic type charts, but they're doing a lot of really cool stuff with the data, including a big public art exhibition that I'm not allowed to talk about right now. So we have a lot of projects coming up. I talked about the Delta. He mentioned the Boiling River and the Bow Glacier, but we're going to the Congo Basin in Cameroon with UCLA to deploy a bunch of sensors. We're working with the Wildlife Conservation Society to do water monitoring across the entire Amazon basin, all 7 countries there. I mentioned the Belize and Antarctica animal tracking projects. There's some work in Sri Lanka later on this year, and a bunch of other kind of random projects that are in the works now. So if you guys are interested in kind of hearing more about FieldKit or knowing when we'll release it, we've fortunately gotten enough funding to take it to public release this year. So we're in the middle of the taking prototypes and turning it into something that isn't ugly phase. But you could go to fieldkit.org and sign up, and you'll kind of hear more about the stuff that we're doing there. We're also building the team, so if you're interested, just reach out to us. We need some expertise in some key areas. So over the next couple months, we'll be adding to the organization, and you can contact us through any of the conservPhi stuff if you want to hear more. So all right, thank you.